Hi everyone, let's take up a question on conservation of momentum. As shown below, bob A of a pendulum having massless string of length r is released from 60 degrees to the vertical. It hits another bob B of half the mass that is at rest on a frictionless table in the center. Assuming elastic collision, the magnitude of the velocity of bob A after the collision will be. So initially bob A is at this position and the string attached to it is making an angle of 60 degree with the vertical. So vertical height of bob A from the top will be equal to r cos 60 degree. This is equal to r by 2. So its vertical distance from the bottom will also be r by 2. So now let's find out velocity of bob A just before it hits bob B. Let's call it u1. This would be equal to root of 2g into h. H is r by 2. So this is equal to root of gr. Let's use conservation of momentum during the collision between bob A and bob B. So therefore m1 u1 plus m2 u2 would be equal to m1 v1 plus m2 v2. Let's assume mass of bob A is m. So therefore mass of bob B would be equal to m upon 2 and initial velocity of bob B is 0. So this equation becomes u1 is root of gr equal to mv1 plus m upon 2 v2. M cancels m everywhere. So this equation becomes v1 plus v2 upon 2 equal to root of gr. Let's call this equation number 1. Since we are given collision is elastic, so therefore velocity of separation v2 minus v1 would be equal to velocity of approach u1 minus u2. u2 is 0. So this gives us, and u1 is equal to root of gr. v2 minus v1 equal to root of gr. Let's call this equation number 2. Let's add equation of 1 and 2. So this will give us v1 plus v2 upon 2 equal to root of gr. Second equation is v2 minus v1 equal to root of gr. So this will give us 3 by 2 v2 equal to 2 root of gr. So therefore v2 is equal to 4 root gr upon 3. Let us put value of v2 into equation number 1. So v1 plus v2 upon 2, this would be 2 by 3 root of gr equal to root of gr. So this will give us v1 equal to root of gr minus 2 by 3 root of gr. So therefore V1 would be equal to 1 by 3 root of GR. So therefore option number 1 is correct. Alright, thank you very much.